2.5, direct variation. Okay, direct variation. There are two types of variation. There's a direct variation and an indirect variation. Back a long time ago, we used to talk about them at the same time. They were right next to each other in the math books, but now they have separated them and put them kind of with the function that they go with. A direct variation is a linear function. It's a very special linear function, and we're going to talk about what that is. But an indirect variation is a rational function, so that's going to be more with the rational functions. Okay? So here's what you need to know. In order for it to be a direct variation, it has to be in this form. Y is equal to K times X. That is a direct variation. Okay? That is a direct variation. This K right here is called K is the constant of variation. Right? K is the constant of variation. Maybe so. Maybe so. Okay? But y'all, a lot of this you really already know. Have we talked about, oh, and let me make a disclaimer here. Our book does not use a K for the constant of variation. It's the only book I've ever taught from that uses another variable. It uses an S. Okay? So I didn't use an S, I use a K. So if you're studying out of the book, they're gonna call this an S. Okay? Every other book I've ever taught out of, they call it a K. I always laugh and tell the kids that they're like, why is it a K? I'm like, oh, because it was math people. And can they spell?
No.
No. So they were like sitting around the table and said, what should we call this? The constant of variation. Someone was like, well, let's call it K because, you know, it's a constant of variation. Like they thought it started with a K. But it doesn't. But anyway, most of the books do call it a K. All right? But have we studied equations in this form right here?
Yes.
Yes. When did you call this K? M. So it's really your what? Slope. So slope and the constant of variation, they're kind of like the same thing. Okay? They're kind of like the same thing. Now I'm going to tell you this. Let's say that we took this equation right here and I wanted to solve for K. I wanted to know what is K equal to. Okay? How would I do it? What would I do to solve for K?
Divide by X.
Divide by X. This is a literal equation, guys. You would divide both sides by X. Over here on the left, the X would divide out, and what would you have, or that's the right. Over here on the left, what would you have K equal to?
Y over X.
Does that make sense? Slope, Y over X. Slope, who goes on top? What is slope? Delta Y over delta X. The change in Y over the change in X. Y is on top, X is on the bottom. Okay, here's another way. Direct variation, you divide. Direct variation, you divide. Indirect variation, we'll learn later on, and you multiply on those. It's Y times X. Okay? So, now let's see. See if you can complete this sentence. In order for it to be a direct variation, in order for it to be, a direct variation, the graph must go through what?
Zero.
There you go. Must go through the origin. So, why? Because y'all look, there is nothing added or subtracted out here. Okay? What's your y-intercept? 0. So it has to go through the origin in order for it to be a direct variation. All right. So how about this? Would you like this for a test question? If I drew a graph and I said, is the graph a direct variation?
Yes.
Would this be hard?
No.
Y'all, there's going to be like 2 of them on the test, and some people are going to miss at least one. I'm like, what? What's wrong with y'all? Where do y'all go during class? Okay? So, I'm gonna draw, here's a coordinate plane. I'm gonna put 3 graphs on it and we're gonna talk about them. Okay? I'm gonna put 3 graphs on it. The question's gonna be, is the graph a direct variation? Okay? So don't say the answer out loud. Give everybody a chance to think about it. There is my first graph, the green line. And I want to know, is this a direct variation? Why?
Because it's not going through the order.
Very good. Y'all, it doesn't go through the origin. Okay? Some people are like, what? Like, okay, so that's all there is? Surely there's something else. No, people, there is nothing else. Okay? What about this guy right here?
Ever since like we know.
No. No. Close, but no cigar. Right? Close, but he didn't quite get there. No. Does not go through the origin. All right? Let this guy right here. Is this a direct variation?
Yes.
Yes. Why?
It goes to the order.
Goes through the origin. Now see, people, this is what I'm talking about. Like, I just said that thing like 10 times, and still somebody on the test is gonna be like, how am I supposed to know if this is a direct variation? I don't know. So what if I did it this way? What if I said, is the equation a direct variation? Should that be just as easy?
Yes. It would have no B.
Oh, it would have no b. The y-intercept would have to be 0. All right, so let me write some up here. Don't blurt the answer out. Give everybody a chance. Y equals 3x minus 5.
No.
No.
No. Why?
It has a B.
It's not in one of the,
It has a Y-intercept.
The y-intercept, this one has a y-intercept too.
I mean, it's not zero.
There you go. That's what I want to hear. Okay? Some of the kids said no because the y-intercept is -5. Does that tell somebody else what's going on?
No.
No, because they're like saying, oh, okay, I'll make it 7 then.
Yeah.
You see what I'm saying? And then you're like, no, that's still not 1. But it's not -5. All right? So the y-intercept is what? Not 0. Now, does that tell me what I'm supposed to be getting? This says, this is why it's not a direct variation, because it's supposed to be a 0 y-intercept, and I got a -5. Okay? All right, what about this guy? Okay, what kind of form is that? Standard form. Okay? Standard form. Is he a direct variation?
No.
No. Does he have a y-intercept? It's what? It's actually going to be -7. You're going to have to divide by -1. Okay? Be careful in standard form, he's not looking the same. Okay? Doesn't always just jump out and grab you like that. What about this guy? Yes? Very good. Yes? If you pulled this little -2x over here and then you divide by 3, he would look just like that y equals kx formula. Okay? What about this guy?
Yes.
Yes?
Yes.
What's the constant of variation?
1.7.
1.78. 1.78. All right. Anybody got a problem with any of these? They're all over the worksheet.
And honestly, you could look the equation up in the calculator and it'll show you too.
Yes, you can. You can always use your calculator. Okay? You can always use your calculator. But
It's
here's the
easy.
deal. If you're gonna put it in your calculator, you have to solve for y. Okay? You can't. Your calculator is only he'll only graph that. Alright, so, on to the next page. Now we're gonna work some problems. Okay, so here's the first one. Example 1. Write and graph a direct variation equation that has -4, 8 as a solution. Okay? Write and graph a direct variation equation that has -4, 8 as a solution. Okay, so some of us are struggling with this concept. How many answers does that question have?
One.
Yeah, it's 2. It says write an equation and graph an equation. Okay? So here's the reason I'm saying this. Could I graph this thing without writing an equation?
No.
Yeah, you could. I could plot that point -4, 8, and then draw a line that goes where?
To the origin.
Through the origin. So I could do that. So some kids get messed up on that. So this thing has 2 answers. First, I want to write an equation, okay? And then I'm going to graph that equation. All right, so in order to write an equation, I need to always find k first. K is, what's the formula? Y over x. Y over x, just like slope, guys, okay? Y over x. What is the y value?
8.
When x is -4. What is 8 over -4? So y is equal to kx. What's my equation?
Y equals -2.
Y equals -2x. Is that hard?
No.
Okay, so now we're gonna graph it. Look what I'm doing, I'm checking myself as I go, okay? What's my slope of this thing? -2, okay? So, I need to be careful there, because negative slopes mess kids up, all right? What's my y-intercept?
0.
And that's good, because it's supposed to be, do you agree? Okay, so 0, 0, and then I use my slope, I'm gonna go down 2 and to the left, to the right 1. Down 2 and to the right 1. And here is my line. I'm always gonna go back and check, my slope is negative, is my line going down? Yes, he is. When you read it from left to right, he is going down. All right, anybody got a question? Okay, so I'm going to give you the same not the same type of problem, but I'm gonna write it in a different way. But y'all, basically, it's gonna be the same thing, okay? So, here's example 1b. X and Y vary directly. Okay, so what am I telling you that we have? A direct variation, okay? And X is equal to 2/3 when Y is equal to -10. Is that the same thing as giving you a point like I did up here?
Yes.
Okay. Write an equation that relates X and Y. Okay, so listen to this. If I write an equation that relates X and Y, what has to be in my equation? X and Y. People, if you're relating X and Y, you have to have an X and Y in the equation. All right? I'm going to show you what's going to happen to some of you. Then, find Y when X equals 12. Okay, how many answers? 2. Write an equation then find y. You got it? Write an equation, then find y. Alright, so what did I tell you that we always find first? K. Okay? K, what does K stand for? Constant of variation. Okay? Constant of variation. Y'all, it is the same thing as the slope. Okay? So K is equal to, what's the formula? Y over X. What is Y? Negative 10. When X is what? 2/3. How do you divide by fractions? No, stop. Y'all listen to me, okay? At some point you have to stop picking up a calculator. You're gonna turn into some kids that I teach and you go, what's 2 times 3? And they pick up a calculator. And I'm like, oh, come on, guys. No, you should know that stuff. All right, so division by fractions is easy as pie. Flip the second and multiply. So times 3 over 2. Put your 10 over 1. What did I tell you to always do before you multiply top times top and bottom times bottom?
See if you can cancel.
Yeah, see if you can cancel and reduce that thing out. It'll make your problem a whole lot easier. 1 and 3 obviously don't reduce. What about 2 and 10? Yeah. 2 goes into 2 one time, 2 goes into 10 5 times. Top times top, what's negative 5 times 3?
Negative 15.
And then 1 times 1 is 1, so it's just negative 15. Do you agree with me?
Yes.
All right, so watch, this is what a third of the kids are going to do on the worksheet and the test, okay? They're gonna write this equation.
It's wrong. It's just wrong.
It is, it's just wrong. People, does this tell you anything about X and Y? People, it says write an equation that relates X and Y. You don't even have an X and Y in your equation. How can that be relating X? Do you understand how that doesn't make any sense? And they're like, well, it's an equation, Miss Davis. Like, where were you? Okay, so use this and write an equation right here that relates X and Y. What's it gonna be?
Y equals negative 15x.
Perfect. Y equals negative 15x. Remember your equation is y is equal to kx. Okay? Now, I'm going to use that equation, y is equal to negative 15x, and I'm going to find y when x is 12. So what am I going to do?
Multiply negative 15 and 12.
That's exactly right. Negative 15 times 12. Oh, 10 times 15 is 150, right? And then 2 15s is 30, and 150 and 30 make 180, so that's negative 180.
Do we have to put y equals negative 180?
No, I'm okay. They said find y, I found it. Sitting right there. All right, anybody got a question? Everybody okay? Was that bad? Okay. So now let's do 2 real life problems. Okay, let's do two real life problems. So the first one is example 2. We're going to talk about hail. This hail, hailstones. Okay, not the very hot place that you don't want to go. All right, we're going to talk about hailstones. Have y'all ever seen a hailstone big as a softball?
Yeah.
Yes.
Have you ever seen a place that was hit by a hailstorm like that?
Yeah. I went to.
It's crazy, isn't it? Y'all, it was the middle of the summer in Monroe, Louisiana, had a hailstorm, and it was the size of softballs. Like, every car looked like someone had taken a baseball bat and beat the mess out of it. The windshields were busted out. Was there a leaf on the trees?
No.
No, all the leaves were gone off the trees. Windows were busted out of houses. There weren't any leaves on the bushes. I mean, it looks like, I don't know, it looks like Armageddon. It was very scary looking, okay? So it's crazy. I'll say this, if the hailstone is bigger than, or if it's the size of a golf ball or bigger, don't go, oh my gosh, did you see that? I'm gonna go get me one. Okay? Because it's gonna knock you in the head. And it's gonna hurt. That's what people do. Because they've never seen one. They're like, wow, look at that, that's so
Back in probably kill you if it hit your temple or something.
Yes, yeah. Crazy people. Okay, so here's what we got. Do y'all know how hell is formed? It's kind of like it's way up there high in the atmosphere, and you got some moisture up there, okay? And it's cold, so that moisture forms a little ball of ice. And then it starts to fall, and the winds are blowing really hard, so the winds blow that little ball of ice back up into that cold area, and it picks up more moisture, it picks up more ice, and then it falls a little bit, and the winds carry it back, and depending on how high the winds are, is how long it keeps circling back and forth and getting bigger and bigger, right? Okay, so here's what we know. That a hailstone with a diameter of 0.75 inches takes 12 minutes to form. Okay? A hailstone with a diameter of 0.75 inches takes 12 minutes to form. So, what is the diameter of a hailstone that stayed up there for 20 minutes?
Can you use proportions or no?
Okay, so this is always, some kids, they're always like, what? Could you use a proportion on this guy right here?
No.
Yeah. Y'all, that's what a direct variation is, a proportion. And so then the kids are like, oh, Miss Davis didn't even know that. Yes, she did. But here's the problem. When you use a proportion to solve it, can you write an equation?
No. Where?
So you miss half the problem. Do you understand what I'm saying?
But can we
It
do it to
is a
check?
proportion. Okay, you can use it to check, and y'all, it is a proportion. It is. It's directly related. You can put X on top and Y on bottom, X on top, Y on bottom. Solve for Y by cross multiplying. But what happens is kids can get this answer, but then they do not know how to write this equation. Okay? So that's why I don't teach it that way. But I appreciate the fact that y'all recognized it. Y'all the first class that's recognized it.
Really?
All right. So, here's the first thing I want to say. I want to find out what is the constant of variation with these hailstones. So, what's the problem? What's the problem? Why do I look
You
at it
don't
and I
know
go,
what
I don't
Y
know what to
is.
do?
You don't know why?
Yeah.
X is always time, right?
There you go. We don't have X's and Y's. Our formula we learned was Y over X. But we don't have X's and Y's. So you have to determine who is X and who is Y. Y'all listen to me. Who is the dependent variable? What depends?
D.
Yeah, the diameter depends on how long he stays up there. Okay? So this is my X and this is my Y. So if I want to know what the constant of variation is, what's it going to be?
0.75.
No. I want a formula.
12.
Formula.
K equals 0.75 over.
Is it the D,
D
over
diameter over
Time.
time. That's what I was looking for. Okay? D over T. A formula. A formula involves some numbers maybe, but in this case it didn't really. All right? So we use the one we know, 0.75 over 12 minutes. All right. So here's my question, because obviously this is illegal. Okay? You cannot have a decimal within a fraction. So my question is, can I write it as a decimal?
Yes.
2 reasons. Tell me what they are.
Tom.
Real life.
It's a real life problem, and I gave you a decimal. Y'all listen to me. If it's a real life problem, you can use decimals, okay? So, if you punch that in your calculator, it will tell you that it is 0.0625.
Yeah.
That is my constant of variation, okay? So now I want you to do this. I want you to write me an equation that gives me the diameter of a hailstone with respect to his time. Tell me what your equation is. D equals,
Oh, yeah, D equals 10625.
5T.
Yeah, I
there
can't,
you go.
the number went right.
Yeah. D equals 0.0625T. Now, do you understand that I could solve this with proportions? Could you do that right there?
No.
No. You wouldn't be able to do that. Okay? So, now can I find the diameter if the time is 20 minutes?
Yes.
So the diameter is equal to 0.0625 times 20, so he is 1¼ inches. Okay, 1¼ inches. Anybody got a question?
Are we allowed to put 1 1/4?
Yes.
Negative 1 or,
Yeah.
wait, so if you get that, okay.
Okay? All right, here's the next problem. This is the last one. This is my favorite problem, one of my favorite problems in our book that we do. So yesterday, I went to the beach, and I went fishing. What did I catch?
A shark.
Yes.
But y'all should hunt sharks.
No. Sharks are
Last time I went fishing, it didn't go.
not
He was such a mean shark. Oh, he
I
was
let go
mean.
of the rod and I lost.
Oh, that's cute.
He looks like a bunny rabbit. So, but I knew it wasn't a bunny rabbit, because there was blood coming from his mouth. I fished an arm out of his mouth. He was so mean.
I drew my own
So
shark.
mean.
But you actually
Okay.
caught one?
No.
Montana.
I'm making this up. Oh,
Ruined the immersion.
yes, he's kind of cute.
Can that be a grenade? Are we blowing them up?
Okay, so here we go. Every time, I caught a bunch of sharks, okay? And every time what I did was I measured the shark's body length.
This isn't you, right? This is just like.
Yeah.
No, she actually is a shark.
Right? Yeah. So, and I measured it in centimeters, because I don't know why. You know, Americans hate the metric system, but whatever. So I measured his body length in centimeters, and I measured the length of a tooth. Tooth length. Okay, and I measured it in centimeters also. So I'll call that T, because B is body length. All right? So the first, one of the sharks that I caught, he was 215 centimeters long, and his tooth was a little 1.8 centimeters. And then the next shark that I caught was 290, 2.4 centimeter tooth. And then my husband caught one 350, it's 2.9 centimeter tooth. That's the only one he caught. Because I'm better than, no. The next one was 430 centimeters, his tooth was 3.6. The next one was 565 centimeters, and he was 4.7. And then, the guy next to us, he caught one that was 695 centimeters, and he was 5.8.
I love how y'all catch all those and the first one he catches is like the best.
No. Okay, so here's what I'm wondering. Do you think that there is a relationship, a direct variation possibly, between the size of a shark's body and the length of his teeth?
Yes.
You think so?
I don't know, is there?
Okay,
No.
I don't
You know
know.
the
I think there probably is. So just because I think there is, I'm gonna go, yeah, there is. No, you have to prove that there is, okay? So, I'll tell y'all a story I told the last class this. So, do any of y'all know Jeremy Evans? Do y'all know who he is? No? Does anybody in here a big basketball fan?
No.
Okay, he plays for the Dallas Mavericks.
Okay.
No? Okay, so anyway, I taught Jeremy when he was in the high school. He's from my old hometown. He was such a nice kid. But we did a little group project in there, and I gave them, first they had to fill out a page, and it had different measurements on their page. Okay, like they had to measure their height, and then they had to measure, there's like 3 bones in a person's body that if they find those bones, they can tell how tall the person is. Okay, now that's like normal. Do you understand? Like that's on an average. Are there probably some people that maybe their bones are that average size, but maybe their legs were extra long? Do you see what I'm saying? They don't really fit the bill. Okay, so the kids had to measure all their heights. So they lined up at the board and their partners marked their height off. Jeremy plays for the Dallas Mavericks. He has won, you could look him up on YouTube, he has won the dunking contest twice. He's an amazing, amazing athlete. He's 6'10". Okay, my husband's 6'5". He makes my husband look like just a normal person. He's giant. When he stood up for them to measure him, first of all, they had to stand in a chair to get to the top of his head, okay? And then he was what? He was off the chalkboard, and they made a mark on the wall. And I was like, what? No marks on my wall. And they were like, it's Jeremy. Like, he doesn't even hit the chalkboard. So, but did he fit that normal curve? No, he was way out of whack. Yeah, he was an outlier. That's exactly what he was. He was an outlier. He was in no way on that normal curve of things. Okay? So here's what I'm saying. Are there going to be some sharks with some giant teeth and little bitty bodies?
Yeah.
Yeah, those are outliers. Weirdos. Okay? Alright? Are there gonna be some giant bodies with little bitty teeth? Yeah, there are always going to be those, but those aren't the norm. So, I want to know, is there a direct variation between a shark's body length and his tooth size? It seems reasonable that there would be. Do you agree with that? Okay, so what do I need to find? If it's a direct variation, what do I need to find?
Some K.
K. Yeah, you need to find your constant of variation. Okay, so what's the formula? Y over X. Y over X. So get your calculator ready. I want some help from y'all. Okay, so I'm going to write the equation up here and then we'll find it down there. What is 215 divided by 1.8? Somebody pop it in your calc.
119.4
Repeating.
So 4 repeating, right? So what's 290 divided by 2.4?
120.83 repeating.
Okay. What's 350 over 2.9?
120.6896552.
689, so I want to say 69. What's 430 over 3.6?
165.39, or 38.
119.4 repeating.
Oh. What did I do?
Okay.
Oh, I
What
did
about
that.
565 divided by 4.7?
120.21276.
2, 1, and 2. So I'll say 2, 1. What is 695 divided by 5.8?
119.83.
83. Okay. So, here's my question. Look at your K's. Is this a direct variation?
No.
Yes.
Yes. People, this is real life. Is real life perfect?
No.
Is it pretty?
No.
No. People, are these numbers very, very close to each other? If I said, hey guys, look at those numbers and tell me what you think K is, what would you say?
120.
There you go. Now, if I was a scientist and I needed to be very, very precise, what would I do?
You average it
I
out.
would average them all up. I would add them all up and divide by however many there were. And I would say, this is K. Do you understand what I'm saying?
Yes.
Okay, so could you do this? Let's say I found a tooth. A shark tooth. Okay? And y'all know who's the good shark tooth finder? Miss Hennigan. Do y'all know Miss Hennigan?
No.
She works in the office. She finds shark teeth all the time.
It's like she just walks around and they're just there.
At the beach, she knows how to find them. I don't know how she does, but she always has a whole bunch. She'll post on Facebook and be like, we found these shark teeth today. What? She knows how to look for them. I don't know what she does. She said she would tell me, but I don't really go to the beach that much. Anyway, so found a tooth, 6.7 centimeters. Can you tell me how big the shark was? Might this be important? Yes. What if the shark bit a hunk out of your side and he left a tooth in there? Right? Could you go, are you going to stop and say, excuse me, sir?
I'd shoot it.
Could I measure how big you are?
Yeah.
Before you bite this hunk out of my side? No, but if I had his tooth, we could tell how big he was. How big is the shark?
But could you put that in proportion?
Body length, what about this? Let's write an equation, since that's what we've been doing, right? Body length is equal to what? 120 times tube size, right? So 120 times 6.7. It was a mega short. It is.
Big boy.
804? I don't even know how big that is. But I think it's pretty good. All right, anybody got a question?
That is 67 feet.
67 feet. That's a pretty good sized shark.
How many centimeters are in a foot?
I'm an American. We say the metric system, even though it's so much easier than any other system that we have. The metric system is amazing because the metric system goes by 10. Listen to our system. 12 inches in a foot, 3 feet in a yard, 5,280 feet in a mile. Like, does that go 10, 100, 1,000, 10,000 like theirs do? No. Yours is so much easier, you're just moving a decimal point. Ours, you gotta multiply by all these different numbers that you gotta remember. How many cups are in a pint, and pints are in a quart, quarts in a gallon. Like, what?
I was on a
Insane.
freeway in Arizona, like by the border, Mexico, everything was in kilometers, and we're just like,
Yeah. All right, Michael, turn us off up there.
I was like, oh heck no.